Hey everyone, this is Ranger Chris here at Mammoth Cave, and this is Cave and Karst Week. So brought out a model to illustrate how water moves through the ground. It's really important to us here at Mammoth Cave. Water is what gives us the world's longest cave at over 412 miles of continuous passageway. So what we're going to do is illustrate not just how water moves, but some of our effects on the water if we're not careful and wind up polluting our underground waterways. Now this model we're going to be using today actually shows us a karst landscape, and that is a landscape that has caves and sinkholes. You'll notice a sinkhole here in the center. Most of the water travels underground. The other side is going to be a non-karst area, and you'll notice how we have empty spaces, and over here we have a lot of tightly packed sand. And this will kind of show you how water moves through both of those landscapes. Now, you may notice it's kind of hard to tell, but you can see where the water line is here on this display. So we're actually going to introduce some pollution into this environment and get an idea of what that pollution does as it travels. So the first thing we're going to do is introduce some pollution into a non-karst area. And you might notice that we have an underground tank here. It's very common that things are stored underground in tanks. And as we introduce this pollution into it, you'll immediately see how the pollution starts to leak out. So we already have a leaky tank. We know that's an issue. We'll add a little more pollution. Now you'll notice how this blue doesn't disperse a lot at first. However, oftentimes we get our water from the ground. We have some type of well that's pumping the water up from deep down, and you'll notice this blue here hasn't moved much, but as I start to pump on our pumping well, and you can see where I have this attached at the top, you can watch the water draw up, and as we're pumping and it's pulling water, then we'll start to see the pollution move through the ground. And depending on which well we pump on will determine how much that pollution gets pulled across. Now this model we have here for you illustrates a karst and a non-karst system. And karst is what we have here in Kentucky, where we have lots of sinkholes, we have lots of caves, most of our water travels underground. And here you can see in this non-karst area that we do in fact have a water line, right? There's a water table here, but there's not the empty spaces that we have down below. And this becomes extremely important to understand when we're talking about pollution. You'll notice that we have put some pollution into our underground tank, and it began to leak, and it's leaching out into the ground. Now that is a problem, but it becomes a bigger problem here in just a little bit. So if I start to pump on this well, right, so we're drawing our water from deep underground, you can see how it pulls the water up the well. And slowly the pollution works its way toward the well, but it's not going to do it very quickly. You would have to pump and pump and pump over a long period to get this pollution to pull through all of this tightly packed wet sediment and over to the well. Eventually it will get there, and that is a problem, but it's a bigger problem if you live in a karst area. In a karst area, the water does not take very long to go from the surface to the subsurface. If we were to add more pollution, even here, you'll see it says point source pollution. We can add some more pollution in there. It'll slowly start to seep in, but it's not going to be a rapid movement of pollution going into the system. So the pollution went in, and it's getting drawn down a little bit, but again, it's not a real rapid draw of the pollution into the ground. Now we'll move over to the karst side. And like here at Mammoth Cave, where we have all the caves and the sinkholes, if it rains and there's anything at all on the surface, it's going to find its way into a sinkhole. Now once it does, you'll notice how it immediately goes into the cave system, right? This is not a slow exchange. This is a very rapid exchange. And for folks in this area who might be using a well, that is a big issue, because as soon as I start pumping and water begins to move, you can see how quickly the pollution disperses throughout that cave system. Now obviously, if there's more pollution, there's more of a chance for that to move towards your well. And it doesn't take a lot of pumping before it starts to draw this water right out of the cave and up the spout. And as it does that, then we start to see how very quickly our cave system can become polluted, our underground waterways can become polluted. Eventually that is going to lead to our well being polluted. One of the most common questions we get here as we're going through the cave, people experience water and they want to know, is the water safe to drink? And in a cave area like this, you would want to be extremely careful drinking any kind of groundwater, because this water, as I said before, can travel for miles and miles away. So any kind of activity going on the surface that might pollute will lead to a pollution in the groundwater itself. And you can see how the pollution has already moved down into this lower chamber and toward our well system, which is not a good situation if you're getting your water from a well in a place like Kentucky. And out west somewhere where we have a much denser soil, and we don't have all that empty space, you can see how that pollution moves much more slowly than it does over here in our karst area. And that's why it's extremely important, no matter where you live, but especially in a karst area like this, to take care not to put any kind of pollutant on the surface, because as soon as it rains, which we get plenty of here in Kentucky, that pollution finds its way directly underground.